All right, ladies and gentlemen, we are going to talk about the connection between exponential and logarithmic equations and look at their graphs. I'm assuming that you've seen this before. I'm going to teach it like you've never seen it, but a little bit faster, perhaps. So as we start this, basically what we needed is we needed a way to take an exponential equation like y equals 2 to the x and come up with its inverse. Okay, and so what we would do, if we wanted to find the inverse of that, you'd switch your x and y, and then we'd need to solve for y. So what we've got 2 to the y is equal to x. We can put this now, this is currently in exponential form, we can move this back to logarithmic form so that we can solve for y. And so that becomes log base 2 of x equals y. And so here's the cheesy little thing. It's 2 to the y equals x. That's a heart, pretend. You see how it's nice and, anyway, it's cheesy. But you've got 2 to the y equals x, and that's what we'd had right there. So that lets us know that we did things correctly. So logarithmic form, I find it very easy to go from the logarithmic form to exponential form. I can do that I heart logs, a to the c equals b. It's a little trickier for me to go the opposite direction. And I always have to double check. So notice the bases here and here are the same. And then it's the exponent is what it's equal to over here. Anyway, that's getting a little cluttered. But that's how we move from one to the other. So let's practice a few of these. They say log base 3 of 27 equals x. So we can say 3 to the x equals 27, which I notice this would imply that this is 3 to the x is equal 27 is a power of 3, so this is 3 to the third. Therefore, x would have to equal 3. Okay, the next one, they've given us x to the fourth is equal to 1 over 64. So, like I said a second ago, I always forget, well, it's log base 4. 4 to the x is going to be over here of this 1 over 64. So, I can go back, I can double check. 4 to the x equals 1/64, which is what they gave me. So, here's what I see here. This is 4 to the x. 64 we know to be 4 cubed. But since it's in the denominator, it's 4 to the negative 3. Well, I don't need those parentheses. I thought there was another x on, there's not. Okay, so therefore x is equal to negative 3. On this one, 25 to the 3 halves is equal to x. You see my little I heart logs. 25 to the 3 halves. The only time is equal to x. The only time that I ever write my fractions with like a slanted line like I did right there is when they're exponents. So for the most part, I would write a fraction in this form right here, where it's nice horizontal line and it helps with the confusion and a lot of things, except I don't always do that when they're in the exponent, because it just gets a little cluttered. Like if I have this 25 to the 3 over 2, you can do that. I just find that I don't do a good job with that writing. So that's the only time that I personally will write a little slanted. Okay, so now let's go back to what this is telling us. I know this implies this is 5 squared to the 3 halves is equal to x. So notice I have power to a power, and I can multiply my exponents. So this will give me now 5 to the third, which means x is equal to 125. Okay, the last one, moving this from logarithmic form, this is log base x of 16 is equal to 4/3. Let's see, x to the 4/3 is equal to 16. Yes, I had to go back and double check. So I'm just proving my point that I have an easy time going this way and not so easy going the opposite. Okay, so let's look at this. What I might say is I might recognize that this x to the 4/3 would be equal to, well, 16 is 2, so 2 to the first is 2, 2 to the second is 4, to the third is 8, to the fourth is 16. So this is 2 to the fourth. Now what I can do is I can raise both powers to this, I can raise both things to the same power. And so what I want to do is I want to raise it to the 3/4 power, so that when these 4/3 times 3/4 gives me 1. So if I do it to one side, I have to do it to the other. This would give me now x is equal to 2 to the third. which is therefore x is equal to 8. Okay, so that was a nice little review for you. Now what we want to do is we want to start looking at these graphs. Oh, this may be old information, SL and HL. I'll have to look. They changed textbooks on me, but I didn't change my worksheets. Okay, so we're going to plot points. We're going to see what happens. We're going to compare these two graphs. We're going to talk about the different components of it. So when I raise the 2 to the negative 2, this gives me a 1/4. Maybe I should write it this way, but it gets a little tight. Sorry, whatever. And then to the negative 1, that's 1/2. Anything to the 0 power is 1. Raise it to the 1, raise it to the 2, raise it to the 3. And so now I'm going to graph these points. So negative 2, 1/4, so I'm somewhere in here. Negative 1, 1/2, I'm somewhere here at, what am I doing? I was just testing to see if you're paying attention. In a perfect world, I'd restart the video. It is not a perfect world. Let's make these positive. So this is positive, this is positive, this is 1. And then when I plug in 1, I get 2. When I plug in 2, I get 4. By the time I plug in 3, I'm off my particular little graph here. And so my graph starts doing something like this. What we're going to do is we notice that this is an exponential growth problem. Notice how as x moves in the positive direction that our y is going up, so it's growing right there. The next thing they ask for, so when they ask for the pivot point is basically what value, how do I get an exponent of 0? And then what's its corresponding y? Okay, so like if I can start shifting and stretching and stuff like that. But basically, I want to know when is my exponent 0. So in this case, the pivot point is 0.01. So let me come down here for just a second. If I took this and I said y is equal to 2 to the x minus 1 plus 3, what this would do is it would shift my graph. It would shift my graph to the right 1 and up 3. So instead of that pivot point, initially it was at 0, 1, I'm going to move it to the right 1 and up 1, 2, 3. So this is that new pivot point. Okay, so it's going to, and then my asymptote, which I haven't talked about yet, is going to move up 3. So it's going to do something like this. So what I do when I think, okay, what's my pivot point? I look to see what do I need to plug in for x to make my exponent 0. Well, if I plug in 1, then this becomes 1 minus 1 is 0. 2 to the 0 power is 1. So 2 to the 0 plus 3, this is 1 plus 3, and that gives me a y value of 4, which is what you can see from my little graph down here. Okay, so the pivot point, what I always think of is how do I make my exponent 0? And then once I figure out what x value to plug in, then I figure out, okay, well, what's the corresponding y value? Okay, coming back here. So now my asymptote, what happens here, let me use this down here. If I have, so say I've got x and I've got, nope, I didn't want f of x. I started to write it and changed my mind. 2 to the x. If I have like a negative, ridiculously large number, then this becomes 2 to the negative, how many zeros did I write? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and that means 1 over 2 times 2 raised to the, that number, which is this in the denominator gets ridiculously big. Okay, so when I have, it's kind of like Miss Kosh has $1 and she's going to share it with everybody in the world. She is so generous. Okay, well, that's kind of ridiculous. But if we all, our 7 billion people, had to share $1, technically we don't have nothing, but it might as well be nothing. But it's not nothing. If we take $1 and divide it by 7 billion people, it's not equal to 0, but it's approaching 0. And for all practical purposes, it is 0. Same idea here. So what happens with our asymptote is that as our x values right here get more and more negative, as they get bigger and bigger, as they move in this direction, we're going to get closer and closer and closer to 0, but we're never going to get there. Okay, so think of that like the $1 example divided by 7 billion people. It's not technically 0, but you're not going to see any money if I take $1 and divide it by the people of the world. So the asymptote is that y equals 0. So the next thing, end behavior always talks about what do I do at the ends of the graph. And so we'll say as x goes to infinity, what's our y value doing? Our y value, as x goes to infinity this way, our y value is also going to positive infinity. And then we'll say, okay, well, what happens as x goes to negative infinity? Well, as x goes to negative infinity, we're now going this way, and we see that we're getting closer and closer and closer to 0. So y would go to 0. What's my domain? Well, I can plug in anything I want into my exponent. So my domain is going to be negative infinity to positive infinity. What's my range? Well, I'm going to get as close as I can to 0, but I'm never going to make it. So it's going to go from 0 to positive infinity. Okay, and now we talked about the log is the inverse of an exponent. The logarithmic equation is the inverse of the exponential equation. And notice what happens here. This is like saying, where do I want to write? They're saying on this first one, negative 2 is equal to log base 2 of x. So this becomes 2 to the negative 2 is equal to x. That's not an x. I was starting to write the 4 from, it's 1/4, my bad. Okay, and so this is 1/4. So it's log base 2 of 1/4 would be equal to negative 2. And then we're going to change this out and say, what happens when it's negative 1? Well, 2 to the negative 1 is 1/2. What happens now when it's 0? 2 to the 0, that's funny. 2 to the 0 is equal to 1. Then we're going to have to do 1, and that's 2, and then this becomes 4, and this becomes 8. Notice these two charts, we've switched our x and our y values, and that's what it means to be the inverse. Let me get rid of that just to clear up some of the clutter. Okay. So graphing this, when I'm at when I'm at 1/4, I come down to negative 2 right here somewhere. When I'm at positive 1/2, then I'm at negative 1, so somewhere in here. When I get to 1, I'm at 0. When I get to 2, I'm up at 1. When I'm at 4, I'm at 2. And I need the point 83, but I don't quite have room for it. Okay, so now this is doing something like that. And once again, well, notice we've just flipped our x and our y's, and what happens is that we flipped our x and y's between these two graphs. What we've we reflected it over the line y equals x. Yes, okay, so pivot point now is this point where I want to get a y value of 0. So, hang on, that's not what I wanted to do. My question is, what do I need to plug in here so that I get a y value of 0? This is that new pivot point. 2 to the, or maybe it's the, what do I want to say? The x value, take the log of 1, and it would equal 0. Actually, I think I'm going to say this to you backwards, because when we start doing our transformations, I want to know, what do I get to make this part right here equal to 1? We'll do a transformation in just a second, but the pivot point here is going to be the point 1, 0. Notice it's we've switched x and y right up there from the exponential equation. Okay, asymptote. Before it was y equals 0. Well, now our x and our y's have changed, and now it's x equals 0. And so notice it's getting closer and closer and closer, but it'll never get there. Then we have, as x goes to infinity, our y value is also going to infinity. And then x can't go to negative infinity. So we'll say as x goes to 0, our y value goes to negative infinity. My domain is now going to be 0 to infinity, and our range is going to be all reals. And you may notice, hopefully, that the range here matches the domain there. And, nope, I don't like orange. And the domain here matches the range there. And so they have flipped. We've switched our x and our y's. Everywhere we've switched our x and our y's. Let me look a little bit at, if we were to say y is equal to log base 2 of x minus 3 plus 4. This has shifted right 3 and up 4. And so what I want to know is, what do I need to plug in to make this whole piece right here equal to 1. Okay, and so what I know is, well, so I can look at this graph back here. If I move it to the, what did I just say? To the right 3 and up 4, 1, 2, 1, 2, 3, and then up 1, 2, 3, 4. Okay, I may have gotten to the wrong spot, but that is where that new pivot point is going to be. I'm going to erase that because that's a little confusing. Okay, so, but if I'm just looking at the equation, I'm going to say, okay, how do I make this part in yellow equal to 1? Well, x minus 3 equals 1 when x is equal to 4. So I've got log base 2 of 4 minus 3 plus 4. Well, this is log base 2 of 1 plus 4. 2 to the what equals 1? Well, this would be 0 plus 4. So we're going to have, so this is, sorry, this is the y value. And so we're going to have this new pivot point would be the point 4, 4. Okay, we'll talk more about transformations as we keep going, but I just wanted to show you how we get the idea of that pivot point, and want to show you the connection between exponential graphs and logarithmic graphs. Go practice. Let me know if you have any questions.